Hello, welcome to another video. Today we are going to solve problem number 197. Find a path in this graph. So if I read the problem description, so you are given a set of edges and then and basically a number of nodes in the graph, and then you need to determine if there is a path execution source and destination. So source is given here, and then destination is also given. So based on this, you need to traverse in the graph and see if you are able to reach to the destination, if there is a path exists. So in this example, this says source is 0 and then destination is true, so you can actually reach from 0 to 2. So there is a graph, there is a path from 0 to 2, and one of the things mentioned is it's a bidirectional graph, so it's not a directed graph, it's an undirected graph. So if you can reach from 0 to 2, you can also traverse from 2 to 0. Same way you can go to 0 to 1 and then 1 to 2. And let's look at the example number 2. So here they are asked if you can reach from 0 to 5. So they both if you look at the graph, so they have 0 and 5 are not connected, so there is no path between 0 to 5. If you start exploring from 0, and then you won't reach to the destination, basically which destination is 5, right? So this is a problem, and if you find a path, you just need to return true, otherwise you just return a false, right? So how do we solve the problem? So what we are going to do is, we are one simple thing is, let's say if we start exploring the graph, then we need to let's think how do we solve using a brute force approach, right? So let's say if we start from 0, and then you need to find what are the adjacent node of 0, so that you can do a traversal, right? In this edges, basically it is not directly given what is the adjacent nodes of 0. So basically if I look at carefully, so in this list I can see that 0 and 1, so there is a path exists between 0 and 1, but this list doesn't say that there is a path exists from 0 to 2, but it does say that there is a path present from 2 to 0. Basically what it says, there is a, so that's why the problem state that it is a bidirectional path, right? So it is a bidirectional path, so there's a path from 2 to 0, and then the path from 0 to 1. So when I draw the graph, so I can say that from 0 I can reach 1. So it's a bidirectional, so I don't need to put an arrow, so I can reach 1. And then if I go further traverse in this particular edge list, I can see that there is a path from 2 to 0. So now when I am at this particular node, so I can see I can travel 2 and 1, right? But I cannot use this list directly to determine what are the nodes I can travel. So what we have to do is, we have to prepare an adjacency matrix. Basically for this particular node, what are the nodes I can travel, and same way for I'll do it for other nodes. So let's say for 1 also, what are the nodes I can travel, I need to find it out, because it is not given directly here. And then for the another node, I need to see what are the nodes I can travel. So I'll use this edges list, and then I'll traverse this list and then try to figure it out what are the nodes available for traversal, and then after that we can do a graph traversal. So once I reach here, the first element is 0 and 1, so I see from 0 I can go 1. Same way for a 1 also I can put 0, because it is a bidirectional graph, right? So when you're putting an edge between 0 to 1, so you have to put edge between 1 to 0. Next I see there is an edge between 1 to 2, so 1 to 2 I can traverse. Then same way for 2 to 1 also, I'll put 2 to 1 as well. And then I see 2 to 0, so I can travel 2 to 0. So when I'm putting 2 to 0, I'll also put 2 to 0 to 2, right? So we form the graph now. Now this particular key value pair that's going to be helpful. So key basically your node value, and then value is a list of edges, or list of nodes I can visit from this particular node. Correct. Now once I have this particular matrix, it is easy to do the graph traversal. So what I'm going to do is, I'm going to use in Python I'm going to use dq, and then I start traversing from 0, and then I'll explore this particular node, to check what are the adjacent nodes, what are the adjacent node I can visit from this particular node. So I'll try to figure it out. So from this node I can see I can visit nodes are 1 and 0, right? Now if any of the nodes are actually equals to the destination, basically if one or so sorry from 0 I can travel to, it's not 1, let me remove this, it should be actually 2, right? Because from 2 to 0, so 0 to, so I can, let me put 2. So from 0th node I can travel 1 and 2, and if any of the node is actually equals to destination, then I'll just return to, I'll break the traversal and then I'll just return. If I don't find any other node, and then I can keep traversing, I'll pick up this node and then I'll try to expand what are the nodes I can visit, and same way I'll pick up this node and then I'll expand. If I don't find any of the nodes which is equal to destination, I'll just return false. That's going to be my false condition, right? So it's quite simple. So let's look at code. So in the code section, as I mentioned, we'll prepare the graph first. So and in the edges, I'll traverse the edges, and then I'll try to create a node between the link between this 0 and 1 or 1 and 0. Basically each node I'll try to connect bidirectional. So if I'm connecting 0 to 1, then I have to connect 1 to 0 as well, right? So I'll prepare this particular dictionary. So dictionary is but nothing but, it is going to be something like this: key value, key which is a node, and then value is a list for that particular node. And then once graph is available, I have created a queue, DQ, and then I'll start exploring the queue. So something, if queue is not empty, I'll keep exploring. So initially in the queue only source is there, so I source basically from where I should I start traversing, and then from 0th node, if I see is this, let's say source is equals to destination itself, then I'll just return to. Otherwise I'll see what are the adjacent nodes of the source. And also I have this visit node, so I don't, let's say I a particular node I already visited, so I don't want to go and visit again, so I'll ignore that particular node. And then I extend the graph. Basically in the queue I'll add the what are the adjacent node of the 2. So in this is going to be, let's say from 0 is going to be 1 and 2, and then again I pop left. So let's say I pop 2 is equals to destination, yes, and then return true. In any case, if I didn't return 2 in here, so by default I'm going to return false, and that will actually uh, solve the problem. You can run this, and hopefully you understand the algorithm what I'm trying to do here. So I'm two basic stuff: create a graph first so that you can explore the edges, adjacent nodes, and then once you uh, prepare this adjacent matrix or adjacent nodes, whatever we call it, and then you can just simply do the traversal uh, to explore if you're able to reach destination. That's it for today's video. Hope you like the hope you understand the algorithm, and then you like the video. Thank you for watching.